Ever wonder how devices on a network communicate with each other? The answer lies in network addressing. This fascinating mechanism underpins the way our interconnected world functions. To understand network addressing, think of it as a city's layout. In a city, each building has a unique address, which allows mail, packages, and people to find their way. Similarly, in a network, each device has a unique identifier known as an IP address. An IP address, or Internet Protocol address, is a numerical label assigned to each device connected to a computer network. It serves two main functions: identifying the host or network interface and providing the location of the host in the network. The IP address is the cornerstone of network addressing, enabling devices to send and receive information. But IP addresses alone are not enough. To efficiently route data, networks are divided into smaller sections known as subnets. This is where the subnet mask comes into play. A subnet mask is a number that defines the range of IP addresses that can be used in a network. It works like a filter, allowing a device to understand which part of an IP address identifies the network and which part identifies the host. Now let's talk about the default gateway. It acts as an access point that a device uses to send information to a device in another network. In our city analogy, it's akin to the main highway that connects different cities. But how do devices know how to translate domain names to IP addresses? That's where the domain name system, or DNS, steps in. It acts like a phone book for the internet, translating human-friendly domain names into IP addresses that computers can understand. Then we have DHCP, or Dynamic Host Configuration Protocol. This is a network protocol that enables a server to automatically assign an IP address to a device. It's like a property manager handing out keys to tenants. Finally, there's Network Address Translation, or NAT. This technique allows a single device, such as a router, to act as an agent between the internet and a local network. This means that only a single, unique IP address is required to represent an entire group of computers to anything outside their network. In summary, network addressing involves several components. It starts with an IP address that uniquely identifies a device. Subnet masks divide the network into manageable sections. The default gateway serves as the access point to other networks. DNS translates domain names into IP addresses. DHCP automatically assigns IP addresses, and NAT allows a single IP address to represent a group of computers. Each component plays a crucial role in ensuring smooth and efficient communication within and across networks. Understanding network addressing is like unlocking the secret language of the internet. It's an integral part of how devices talk to each other, bringing us the connected world we know and rely on today.